In this video, we generate the trend line and data set of the Rayleigh distribution function with its probability density function and the cumulative distribution function. We begin with the value of sigma, which is data validation, list of items, and our value for sigma is from 1 to 3. So save. So it is from 1, 1.5, 2, 2.5, and 3. We can start with 1. And our value of k is data validation, list of items, 0 or 1. 0 or 1. 0 if it is probability density function, 1 if it is cumulative distribution function. Now we continue with the probability density function, which is our formula of the x values times e raised to the power negative 0.5 x squared over sigma squared. So minus 0.5 times x squared, so raised to the power 2, divided by sigma squared, so sigma raised to the power 2, and the whole expression divided by the quantity sigma raised to the power 2, and close the formula and enter. And we continue with the cumulative distribution function, which is our formula 1 minus e to the power 0.5 x squared. So 1 minus e to the power negative 0.5 times x squared. So x raised to the power 2 divided by the quantity sigma squared. Sigma raised to the power 2. And we close the exponent. And we calculate the Taylor-Maclaurin series sum for both. So we chart this, insert chart, and we'll use scatter chart. And we show the trend line. Polynomial raised to the power to the degree 6. And equation label and the position at the bottom. We set this aside. Continue with the polynomial regression coefficient later. Then the series sum, the Taylor-Maclaurin series sum, which is equal to x times the summation of a times x to the power 2n plus k over sigma squared, where a is this coefficient and n starts from 0 up to infinity. In this case, 16 is good enough. We continue with the coefficient, which is our formula, negative 1 raised to the power n, divided by the denominator will be 3 parts. The first part is factorial n plus k. The second part times the 2 to the power n plus k. So 2 raised to the power the quantity n plus k, n plus k. That's the second part. Now finally the third part. Sigma raised to the power 2n. So sigma raised to the power the quantity 2 times n. The third part. Now enter. continue with the series sum now. So array formula of times x, or x times the series sum, the summation. The summation of a times x to the power 2n plus k. So x raised to the power 2n plus k, where 2n plus k starts from k, incremented by 2n, so 2. And the coefficient will be a, and enter. And the whole series sum divided by sigma squared, so sigma raised to the power 2, and enter. So we can toggle this at k equals 0 or k equals 1. They're the same. K equals 0. They are the same. And we show the trend line. So we'll modify this series. We don't have a yellow, so we change this color to green. And for all the series, show the trend line, polynomial to the 6th degree, and show the equation as label. And in case of the polynomials, the point size will be maximum, except for the expansion, there will be none. So this will be none. The point size is none. But the trend line, the line thickness will be maximum. So that when you can toggle between, and if you increase this to 1.5, and you can still toggle between 1 and 0. We calculate this polynomial regression coefficient using Linus. To do that, we first claim this. We want this simplified, so we go to the vertical axis. The number format will be none. Now it's better. We'll use Linus to calculate the polynomial regression coefficient. Starting with the power, which is transpose 0 to 6. And the elements of the matrix, which is equal to array formula of the x values raised to the power 0 to 6. And we calculate Linest. So Linest data y and data x. That's for the probability density function. So Linest for the expansion, data y and data x. And finally, the cumulative distribution function, which is Linest data y and data x. So we can look into the coefficients. So we start with 1. That's 0 or 1. So the coefficients X to the 0, 0. This is 0 because it's times 10 to the minus 32 times 10 to the minus 33, that's 0. X 0.913, and this is 0.746, 7.4 times 10 to the minus 3. This is 0.436, 0.523. This is 0.13, 1.31, 2.04 times 10 to the minus 3, 1.86. And x to the fourth. This is 7.716, 0.181, and 0.181. X to the fifth. Minus 0.159, 6.8 times 10 to the minus 3, 6.87 times 10 to the minus 3. Minus 2, this is minus 2. And x to the 6, 0.0129 and 7.77 times 10 to the minus 3. So we can continue with we can toggle this expansion approximates the probability density function, and their polynomial regression coefficients are the same. If we toggle this to 1, the expansion approximates the cumulative distribution function, likewise in the dataset as well. At 1.5, you can toggle to 0. At sigma is 2, you can toggle to 1. At 2.5, you can toggle to 0. And at 3, you can toggle to 1. This completes the Taylor-Maclaurin series sum and Linus polynomial regression of the Rayleigh distributions in the probability density function, cumulative distribution function, using ARRAYFORMULA, series sum, and Linest.